Well, it says we're live here, so let's see if my audio is working. Hopefully, this is getting through. We're going to start the presentation in about 10 minutes or so. It's a little bit before 6:30, but we're just starting the stream now. Maybe about 5 to 10 minutes, we'll go ahead and get started. Okay, so I think then we just need to ask her to kick it off. Okay, well, I will hang out here. It's gone.
Oh, now you can see it.
Great.
I will hang out here. It's gone. Okay, so it looks like it's coming through.
Just a little delayed.
Yeah. Oh, it's live.
Yep.
Now, can you check how the chat works? Am I talking? Well, you cannot talk. Okay. As an audio.
Hey, everyone, in case you're online, we're going to be starting in about 5 minutes or so. All right. Hey, everyone. Thank you for joining us online. We're just waiting a few moments before 6:30. We'll be starting in a minute. All right. We've got about 3 minutes until we get started. Thank you all for joining early. We'll kick off with data analytics and movie box office numbers in about 3 minutes.
Hi, we're just um, getting ready to get started. So we'll probably just give it another like 2 to 3 minutes and then we'll start our presentation. Okay, I think we're going to get started. Welcome to this month's edition of Big Data.
No, it's still working. It's just that the mic is muted from my computer. It's showing.
Bellevue. My name is Siddharth Agrawal. I'm the organizer of the Meetup and my co-organizer is Chaitanya. Um, we're here at the Microsoft Reactor with, in-person audience as well as folks online. So just a little bit of history about our meetup. This meetup was formed, I guess, almost a decade ago um, in kind of the heyday of big data when in those days we were still using Hadoop. But I've been running and organizing this meetup. And over the years, I've always seen this field has just continued to grow with a whole bunch of new technologies. And like I know I personally have benefited from learning, to hear about different technologies out there. One of the common themes in big data is around analytics. Like that's generally, in the old days that used to be called databases, and using databases to get, metrics about how your business is doing. And these days that's all done in the cloud at much higher scales than ever possible before. And this meetup is kind of about what are the technologies that go into that to enable that kind of processing. Um, and we get to hear from businesses as well as from academia to get insight into how this technology works. This evening we have a presentation from Bellevue College on how analytics are taught these days in school. And so that will give us a great overview of the type of things that students get exposed to, how you learn to do analytics, what kind of insights you can gain from them. As well, we'll also get some insight into the history of how this course came to be. Um, so for the folks who are online, if you have questions, you can type them in the chat, and then we'll answer them, or else you can just wait till the end and then we'll take questions. It's up to you. So our speaker today is Ted Spence, who is currently teaching at Bellevue College, and he has come from industry, so he has the background of knowing what the industry is doing, and he's going to tell us about how he teaches data analytics using movie box office numbers, as a motivation. But with that, let me hand it over to Ted.
Thank you so much. I really appreciate the kind introduction. I want to say a thank you, first of all, to Big Data Bellevue. It is really a pleasure and a privilege to be invited out here to talk. And I'd also like to say thank you to Microsoft for hosting us at this gorgeous building. I mean, I really love this campus. I've only been here once or twice, but it's just a gorgeous location. It's lovely to see so many people in person, and hopefully we'll have lots of you online as well. Anyways, my name is Ted Spence. And as it was mentioned, I would love to think that I know what's going on in data analytics. I would love to think that I know what's happening, but I really don't. Because no matter how much you learn, there's always more that you can experience. And part of what I'd like to share with you today is just my journey to how I practiced and tried to figure out a useful way to share the little tips and techniques that I'd come to along the way. So let's jump in, shall we? What we're going to do for today is I have a talk with 4 sections. I'm going to talk a little bit about the background of how I got into this field. I'm going to talk a little bit about why I became a teacher and how it kind of came to be that I was teaching data analytics. I'm also going to talk about the curriculum that developed for this course. So I've had the good fortune to be teaching the same course for a couple of years now, and I've worked to try to refine away the things that were not working, that were not helping students learn, and to gradually focus more on the things that were successful, that were engaging, and helped students get towards success. And then finally, at the end, I will feature a selection of slides from my students' presentations where they showed off some truly amazing work, way above and beyond what I normally expect a student to be able to achieve. And this was done with relatively simple tools, and I'll walk you through this and I'll show you just a little bit about how it was done. So anyways, I'm going to start off with some penguins. So naturally, penguins are the right way to start any talk. I like to use this slide partly because this was my favorite vacation in 2019 before the pandemic hit. But it's also worth saying that no matter how cute a picture of penguins is, it's not the same as being there in real life and seeing the penguins in person. They are literally the most adorable little creatures. They waddle along. They couldn't pay any attention to people if they tried. When I visited at the time, these penguins were all sitting on eggs, and some of them had little hatchlings and little adolescent penguins, and it was just the most wonderful, adorable thing. So if any of you are lucky enough to have an opportunity to take a vacation and visit a penguin rookery, I highly recommend it. If you get nothing else out of this presentation, maybe you'll get a desire to visit penguins in the wild someday. But anyways, about me, I have been writing software since roughly 1978, 79, when my father brought home a Commodore PET with an embedded cassette drive. And he brought this home because at the time he was working on making printers. And he was partnered with a company in Japan called Seikosha, which of course is today known as Epson. And they made a lot of printers for the early personal computer era, the early 8-bit era. And as a result of that, he just brought this computer home and let me play with it. And I just got hooked. And so I've been writing software ever since then. I've done a lot of database applications. I've done a lot of multimedia work. Like any young person, I was fascinated with video games. And so I got really interested in doing programming for video games. But for various reasons, I wound up in the professional world not doing video games. So I'll tell you a little bit about how that kind of colored my career. I've done a ton of different things. I worked for Vivendi Universal, which was the parent company of Blizzard in 2003. That was absolutely amazing. I joined EDAR, which was an analytics company in 2007. I was the employee number 3. I served as CIO. Joined a company called Avalara, which is well known in Seattle nowadays because they went public, and very proud of the work that I've done there. I joined Facebook, and eventually, even though I was at Facebook, and Facebook is a magnificent company, I eventually got the startup bug again. And so I've joined a few startups. I joined Lockstep. It was sold to Sage. And now I've joined another startup, and hopefully we'll sell that one off in a little while. We'll see. But anyways, it's an amazing experience. I also grew up in Los Angeles. And growing up in Los Angeles, you read the newspaper all the time, and there's always a big entertainment section. And so we would read the newspaper. I would be, just browsing through the paper in the mornings in the 80s and the 90s. And I would read about the latest movies and the box office numbers. And you would get this little sidebar, and it would look a little bit like this. And it would say, here's the weekend's top box office numbers. And it would tell you just a little bit of context. Somebody would have a little blurb to the side that says, this movie did really well, this movie did badly. You would wind up with a blurb that would talk about declines. And so what it would say is that a movie, when it came out, would have a big smash weekend, an opening weekend, and then gradually ticket sales would decline week over week. So I just kind of grew up knowing this. It was just kind of like easy to see this in the newspapers, but I never knew what was behind this. I never knew like whether this was a real theory or if it was just, this was the way people talked. So I started off with a couple assumptions, and we should recognize that anyone who's going into a data project has to identify their assumptions up front. You need to say, I'm going into this data project and I expect to find that a movie has a quality score. I expect to find that attendance declines at a movie week over week. There's a big opening and it's going to go downwards. And then the final thing is that I'm going to make the assumption that higher quality movies have a smaller decline week over week than lower quality movies. Those of you who have as many gray hairs as I do may remember the movie Titanic, which was probably one of the longest lived modern blockbusters. It was in theaters for almost a full year, I think, continuing to draw audiences month after month, week after week. And, it was because the movie was such a high quality movie, because people really liked it. So we have a couple assumptions about the movie industry, and I just kind of absorbed these by living in Los Angeles and just kind of skimming the newspaper growing up. So later on in my career, I had a phone call from a friend of mine. And this phone call was from a friend of mine who had just been responsible for a smash hit video game called EverQuest. He was one of the key designers of EverQuest. And he said, I'm going to step out of making video games for a little while. I want to have data to help people make video games. And I asked him about this. And, I was lucky enough at the time to have less gray in my hair. You can see this professional headshot that we had at the time. But we talked about this and we came up with an idea for a company. And the company was this firm called EDAR. And we decided that we were going to do analytics and we were going to provide services and help people make better video games. And the reason for this was that while designing EverQuest, everybody had an opinion about something. Everybody involved with the game had an opinion, and it was really hard to figure out whose opinion was right. So he wanted to have data and he wanted to make decisions with this. So we decided to come up with a company to put this together. And so we started gathering some facts, and we created software to run reports, and we created some metadata around the games that we researched. And we went out to all of the video game developers and we said, here you go. Here's a whole bunch of information that we have that can help you. Well, the next thing that we discovered was video game developers are broke. And this is kind of a bummer because the video game developers wanted to do the right thing. And they really wanted this data, but none of them had the resources to pay for this information. They were essentially the starving artists of the video game world. These developers were basically the equivalent of an actor who was bussing tables at a restaurant waiting for his big break. Um, and so essentially we tried to figure out, like, what are we going to do with this? We've come up with this business and we wanted to help developers. What is the alternative? What else could we do? And how could we make this happen? So we kicked these ideas around for a little bit and we said, all right, what is an alternative approach that we could take? Well, we went to the video game publishers and we said, we've gathered all of this information. What is it that you want? Because in the video game industry, it's actually handled very much on the Hollywood model. The video game industry works by a publisher deciding that they're interested in a particular segment of the market, and they invest some money in a small developer. They take a game, they launch it, they market it, and they see if it's a hit. And if it is a hit, then they'll get excited, they'll contract the developer to do a sequel. But if it isn't a hit, they'll say, you know, we're sorry, this didn't work out. We're going to go find somebody else. And it's very much like the way a Hollywood movie works. So the movie will basically be brought together, a whole bunch of actors, a whole bunch of producers, cinematographers, set designers, everything. They'll bring them together for the movie, and then they'll vanish after the movie is done, and they'll go back into the mix and come up with the next great movie. So we talked to these publishers. What did they want to know? They wanted to know how many units they should make, because they basically had the same problem that the Hollywood studios had, which is that when a game comes out, there's a lot of interest right away. Everyone buys it right away. And only the most successful games keep selling week after week, month after month. So the publishers knew that there's a short window of time after a game launches where you can sell a lot of product. But if you produce too much product, then you wind up with tons and tons of unsold boxes. And those unsold boxes, they cost a lot of money to produce, and then you have to put them on clearance. And when you put them on clearance, your video game gets kind of like a bad taste in people's mouth. They're like, why is it on sale? It must not be that good. So the video game publishers told us that they really wanted to get more accurate forecasts for sales. So I kind of, racked my brain and I thought about this and I said, well, I kind of had these assumptions about how the movie industry works. Maybe that would be useful. So we dug into our repository of all of this data that we had collected for video game developers. And we said, how can we forecast sales for publishers? Well, we had a whole bunch of facts. And we also had custom research that we had done. So we partnered with people and gathered data from existing sources, things like review scores. We wrote custom-built web scrapers to gather facts. We partnered with various gaming websites to use their page view data for articles about games. We licensed data sets, and we asked the publishers if they'd be willing to share some of their internal data too. So we had a whole bunch of raw facts. And then the final thing is we gathered our own data. And what we did is we made a list of features that a video game would have. And all of those features, we then hired people to scan through video games and check to see whether each feature was present in each video game. The theory was that if we studied all of these features, we could eventually figure out kind of like a signature of what made that game unique. And that signature could potentially help us to figure out what sales this game would have. So we took all of this information and we put it all into our massive, highly sophisticated big data engine in 2007. And I'm sure you can imagine I'm using highly sophisticated with air quotes here. And what did we come up with? Well, bad luck. We didn't get good results. So let me walk you through the state of the art in 2007 and talk you through what we tried. So the first thing we did is we took these charts and we just dropped them in Excel and we plotted them. And frankly, that is still one of the most useful tools that exists today, because Excel gives you a sanity check. If your Excel chart shows something, and your database shows something different, you need to dig into that. You need to understand it. You need to research a little bit more. So we would start with these Excel charts, but then I started trying to do linear and multivariable regression. So talked to some people, asked for some advice. They suggested regression. And I ran the regression reports, but they just weren't coming out that great. And I wasn't sure why. And so I tried more complex regression models and I tried simpler regression models. But as I'm sure you can imagine, the R value was just not good. And so I was really scratching my head about this and I was not sure what I did wrong. So then I read some papers on Bayesian analysis. And I said, well, I've got a whole bunch of true false facts that we have researched about the presence or absence of features in video games. What if I did a Bayesian analysis to try to figure out true false correlation with end results of sales? And I tried writing some custom software for this. I tried experimenting with a few different approaches. It's just nothing really encouraging. I then experimented with neural networks. At the time, there were some very, very rudimentary open source neural networks and downloaded a few copies of them, and they were just not ready for the market. Back 20. Sorry, this was 15 years ago, I think. Yeah, 15 years ago. So then I also tried another thing, which was generational models. I tried just writing a simulator that said, let's take all of these factors from regression and Bayesian and whatever, and let's just randomly mutate them and try to measure success. And I ran like a whole bunch of computers on this. Again, didn't really produce anything. So after tinkering with this for a few weeks and trying all of these different approaches, I kind of said, look, I need some better advice. And at this point, I was introduced to a math professor. I was introduced to a colleague who had some background. And what they said was, look, here's the reason why you're not getting good results. You're doing a regression model, but your regression is on absolute values rather than logistic values. And so we had these sales figures and we were trying to estimate actual sales figures. Rather than trying to estimate actual sales figures, we should take the natural logarithm of those figures and try to forecast that. And the benefit here is that this gives us more granularity over an exponential scale, more accuracy over the exponential scale. Because fundamentally, the difference between a video game that sells $200 million worth of units versus $250 million of units, that's a smaller difference than one that sells 10 million or 20 million. So once we started looking at this logistically, we got much better results. And I should mention here, I'm using the finance term or the finance indicator which is kind of like just shows up in certain instances. Is just used to mean million. And I guess is a Latin derivation or a Romance language derivation. So with this information, we actually got a lot of better regression results. But the final step that we got, oh no, the equation didn't show up. When we imported this, the equation did not appear. So I'll have to talk you through this. This is a PowerPoint slide that includes a formula, but it looks like it's not displaying here on this screen. What happened was, after we gathered all of these facts, we started getting much better R values for things. And we then added in a final data source that was marketing dollars spent. It was a research estimate of how much we thought each company was spending marketing a video game. And so once we had marketing spend and page views on consumer interest websites, those two things plus the aggregate quality score based upon reviews wound up being a really reliable forecast of game sales. So the money you spend on marketing plus the consumer interest, which is kind of a measure of the success of your marketing, plus the review score, which represents the reaction of the outside world to your product, those three things together produced a formula that was solid, reasonably reliable, not perfect, but better than anything else. And we would keep trying, like every few months or every year or so, we would try adding in a new data point. And that new data point would be promising, but it would never really factor up. It would never really be strong enough R value to include for the long term. So anyways, this was a great project and we really liked it, but eventually I moved on. You know, that company got sold off to NPD. I went and I joined Avalara, moved up here to Seattle. Sooner or later, I got a question from a colleague, said, would you ever consider teaching? And Bellevue College reached out to me and I met with them and I really liked everything I saw. Bellevue College, very grateful for the opportunity. They have an incredible campus. They have fantastic students and they offered me an invitation to teach. Uh, they wound up talking to me about a couple of different classes where they needed some help. And as it turned out, there was a data analytics professor that had taken a sabbatical and they needed somebody to pick up these data analytics classes while there was a teacher on sabbatical. So I said, all right, well, I did this project a few years back for EDAR where we analyzed video game data. I could probably do something like that to help this professor while they're off. So what did they ask me to do? They asked me to teach a class called DA 460. And DA 460 was what was called a capstone class at Bellevue College. It was the capstone class because it was intended to be the last course you would take at the college before you graduated, before you like went off and used your degree professionally. And so they talked to me a bit about the class, but they said, you know, the curriculum is kind of free form. These are students who've already proved their capabilities. So I said, all right, well, how about I set up a class where students do a data project of their own? Great. You know, I'll talk them through it. I'll coach them. But I needed something that I could demonstrate. And obviously at this point, I was no longer with EDAR, so I couldn't just pull game data anymore. You know, it wouldn't really be ethical to like go back and, you know, ask them to share a bunch of confidential data with me. So instead I said, well, how about I use superhero movies? You know, I can do some reports and show people how the latest Avengers blockbuster is doing. And, you know, I figured that would be a good context. So I would encourage students to do their own project, but I would show them some numbers from superhero movies and talk a bit about that. All right. I also love history. I'm really fascinated by the way that computer science has developed over the past, you know, 35 years. I've been doing this professionally since 1990. So I was like, oh, how about I tell people about the cool things that I've experienced over the 30 something years? You know, it was a chance for me to mix my personal interests into the course. Hey, it sounded like a fun idea. And then the final element was that because I was working at Facebook at the time, um, I imposed on Bellevue and I said, like, is there any way I could teach this in the evenings? And they said, that's great, but please just do it completely online. Now, this was 2019. This was before the pandemic happened. They said, just please teach completely online. I was like, well, all right. I wonder what a completely online class would be like. Well, I need some way to interact with the students. So, you know, could I do videos? Could I do anything? Well, I added discussion boards into the class. And I said, all right, well, I'll ask the students to talk to each other and talk to me, and they'll submit their assignments via these discussion boards. Okay, seems like a decent attempt. Well, the discussion boards turned out to be the best part of it. These students were completely asynchronous, and most of them either had day jobs or they were already working professionally and they were trying to get a degree to increase their career prospects. Well, they loved the ability to work with other students, even if they were logging on at 1 a.m. at night, even if they were only doing some work in between other classes. And so what would happen is I told students, you need to communicate about your homework with other students. You need to share what you're discovering, and other people can get points or grades for helping you out or for collaborating. This was a huge success, and I continue to use this today. The really important thing here is insisting on this interaction. And I tell students all the time that this is good practice for the professional world, because if you just lock yourself into a cubicle and you just do your work and go home at the end of the day, you don't have an opportunity to join amazing events like this here, Big Data Bellevue. I love coming out here and talking to people and hearing all of the great things that other people do. I tell all of my students, practice this, practice discussing your work. I don't mind if you collaborate with other students to do your homework together. I just want to see you write up your problem, share it with someone. If somebody finds a solution, write up the solution and share it. Get in the habit of sharing your work. So I encourage this, and I also do a lot of blogging. My personal blog is tedspence.com. If anyone would be willing to type it into the text, it would be greatly appreciated. I would love for all of you to follow and write comments on my articles and things like this. I'd love to be able to share this. I spent far too long in my career not talking about my work. Best advice I can give any of you long-term is to talk about your work. Talk about it, share it, and you'll be much more successful. So I wrote up this grading rubric, and I tried to come up with a fair way to do this, because some students are shy and some students are absolutely the most outgoing people ever. And I'll know within a few classes every year whether a student is going to be on one side of the fence or the other, but I wanted to make it possible for everyone to get a good grade. And so I came up with this rubric, and basically, I'll give you 1 point if you just write a comment in the discussion board. But what I'm really asking you to do is find something relevant to the class and share it. So I encourage students to find a link or a video or something along the line and share it. And if you can do that, that's a 2 point. But then you go to the more interesting stuff. What I really want to see out of students is I want to see them collaborating with each other. When I went to college, I took a philosophy class, and I loved philosophy. It's absolutely fascinating. It's a collection of history and theory and ideas, and like philosophy has so much weirdness in it that I loved going outside of class at break time and debating with my fellow students. What do we think this means? So all I want to see when students talk about data analytics is, are you interacting? Are you collaborating together? Or do you actually help somebody solve a problem? So I'm trying to encourage students to get a good grade here, and I try to make it clear to them, this is what you need to do in order to get 5 points, which is the full point score for a graded discussion. And so every time a student participates, I try to tell them, this is how many points you did. Please try to do this next time, and build your confidence, build your ability to share and collaborate. The other thing that I did is I started teaching with PowerPoints. And some of you may notice that nowadays, teaching with PowerPoints can be a problem. So it's very dangerous to get PowerPoints with lots of text on them. So I have to teach myself to not just read the text off of my slides. It's actually really tricky because you see the text and I want to read this. I want to say text on the page is a reminder of a topic. But actually what I'm trying to do is I'm trying to put this text up there as a way of just prompting me if my mind goes blank for a moment. I want to have a fun, casual presentation with everyone. I want to get to the part of our presentation where we ask questions. So here is where I will also remind you, if you have questions, please do put them in text. We have some colleagues here who are going to be keeping track of those and sharing them with me when I can get to the questions. But I also use this to practice, and I kind of have measured myself a few times. If I go at a normal pace, I can do about 1 slide every minute. And that gives me enough time to digress, to chat, to goof off, to like talk about penguins and things. Gives me a chance to be silly, but I can still keep the presentation moving forward. And then the answer is that I also worry very deeply about students who miss a class, because students have a lot of time pressures in their world, and sometimes they just won't be able to make every individual lecture. So I want to make sure that my PowerPoints include all of the meaningful text so that if a student wasn't able to attend the lecture, they can at least read what was shared and catch up. So I taught DA 460 and the results were mixed. I got about a 50-50 result. I'm sure you all, those of you who are in the professional world will know NPS scores. But those of you who are in the academic world, you probably know student evaluation surveys. Student evaluation surveys are basically just another form of NPS. We ask students, did you like the class? Did you not like the class? Well, I taught DA 460 and the results were about half-half. Some of the students liked it, some of the students didn't. And the answer was that most of the students who didn't like the class, they picked a data project that wound up being frustrating. So I thought about this, and obviously this was intended to be a capstone class, and I wanted students to have the freedom of choosing whatever data set that they wanted to do. But one student picked a data set about travel times on a bike route. And the data set was really interesting, but there was no good analysis that could come out of it. So the student did lots of work and spent a lot of time on it, but just the end results were kind of frustrating, and that colored the student's experience of the class. Another student wound up doing basketball scores, and I wouldn't have thought that basketball scores had a lot of really good, interesting results, but as it turns out, they did a solid paper explaining how shot attempts was a critical metric in basketball games. And I was like, oh, wow, I didn't know that. That's great. So really, my experience was that teaching this first class, my very first class that I ever taught, teaching it, it was a problem. And it was a problem specifically because the variability of the data meant that some students had a good experience and some students didn't. The other nuisance was that when I went back and talked about like 30-year-old stories of the computer industry, students dropped out of the lectures. Like they just didn't show up for those lectures where I said, I'll talk about the history of databases. They just weren't interested in that. And then the final thing that was an interesting challenge was that a lot of students hit general IT problems. When I got to the section of the class where they had to do something project related, some of them would have problems installing software. And I just thought, that's kind of interesting. I need to figure out a solution for this. So the next thing that happened was that Bellevue College invited me to teach a different class called DA 320. And if you can't read this whole thing, it's not necessary. You don't need to read this whole course description. But the summary was that DA 320 was a class on data acquisition and management. And I'm like, you know what? That is exactly what I did at EDAR. I acquired data by partnerships and by scrapers and by research, and I managed it and ran reports on it. How about I teach that? So the next thing I did is I went back to a whole bunch of colleagues and said, what could I do to make this better? And of course, since this is a talk about movie analytics, I'm going to be putting in some random movie stills here. If anyone recognizes this one, this is a very classic 1992 film called Sneakers, because the very first suggestion I got was, what about data ethics? And the movie Sneakers is all about the ethics of data breaches and theft. And it's all about people breaking into a data center and stealing technology and things like this. So they suggested, why don't you teach a little bit of ethics to how do you manage data? What does it mean to supervise a data set? What is a good data manager? Another suggestion that people had was, why don't I record videos of myself giving these lectures? Okay, great. I'll try recording them and I'll put them on YouTube and I'll share them with students. Great. Another suggestion was find a book and add a book to the class. So I did some research and I found a book that I thought I'd really like. And then the final thing was that I met another teacher on campus who suggested, hey, have you considered adding, climate justice was her topic. And I said, well, that's a really interesting idea. I wonder if I could find a data set that included some climate information. So all of these suggestions I put together, and I wanted to get a better data set in general. So I said, let's focus on this movie box office numbers. When I did my presentation materials in DA 460, I was mostly doing movie box office. And I was showing people, here's how to run regression analysis, here's how to run reports, here's how to do charting using movie box office numbers. And I was like, okay, great, I can do this. Movie box office numbers are generally public domain. You can visit pretty much any website in the world and you can find public domain movie box office numbers. Some websites say that their movie data is proprietary, but there's another interesting thing, which is that movie data is technically, movie data is, even when it's commercial, academic use, researching that is generally considered fair use. So I added a section to the class where I talked about what is fair use and what are the positives and negatives of it. I also generated a fake data set. I ran a simulation and attempted to simulate fake tweets because I didn't want people to use real world tweets. I didn't want to set up a class where there was like the risk of using some personally identifiable information. And then finally, I just said, all right, well, I'm going to combine all of this and I'm going to teach it the way that I did my EDAR data analytics work. The next thing that I chose to do is I dropped R. I was originally teaching using the language R, and the language R was really interesting, but just like, it felt like I was teaching something very unique that the skills that would be learned in R wouldn't really leverage to anything outside of R. On the other hand, if I was doing web scraping was a perfect tool to be done in Python. And Python and Jupyter, of course, had a lot of overlap. So I thought about this and I talked to some colleagues at Facebook at the time and I just said, you know what, I'm going to drop R completely. I'm going to teach everything in Jupyter. And Jupyter notebooks have turned out to be a good suggestion. They've made the class a little bit easier to manage. I've also stopped using Jupyter directly, and I've just taught people how to use the Visual Studio Code with the Microsoft Jupyter plugin. And that's generally been easier. One by one, each simplification of this reduced the number of IT setup problems that students had. I did finally find some climate data, and this is by an organization called IRENA. And this data was so fantastic, I realized that I couldn't actually ask students to analyze this data themselves. What I would do instead is to share this and talk about how useful these charts were, how well constructed these charts were. So this chart that you're seeing right here is absolutely my favorite. And because I talk about this work, I've gotten in touch with the people at IRENA who created this report. The guy who does this is an incredible colleague. He does amazing work and he publishes fantastic charts. What you can see right here is that looking at this renewable energy data, the yellow bar in the middle shows that 10 years ago, solar photovoltaic power was dramatically more expensive than fossil fuels. And in the past 10 years, we've essentially gone from solar photovoltaic being cost prohibitive to it is now cheaper than most fossil fuel projects. So with this information, it's been absolutely fascinating because every day new research comes out and new publications come out talking about how amazingly successful renewable energy is. Nowadays, it is actually cheaper to demolish a coal-fired power plant and put in its place a wind farm than it is to keep operating the coal-fired power plant in the first place. Really fascinating stuff. Originally, I had wanted to find data on recycling, but there's just no good data that I could find, and I just abandoned that idea. So this was actually a really interesting addition, and it helped me to show people this is the kind of chart that we want to produce, a chart that tells a compelling story. And so I'm going to show you at the end of this presentation some of the charts my students have produced about movie box office numbers. Next thing I did is I decided to dig in and explain to students a bit about how you can retrieve data from websites. This is a slide from one of my talks at the class where I show people, oh, if you were interested in gathering price data off as Amazon, this is how you would do it. You would look for facts within HTML and scrape them out. I'm even more fond of teaching regex 101 because regex 101 I feel is one of those amazing skills that really gets shortchanged. If you learn regular expressions, there are so many tools that will wind up using this. And I demonstrate with slides like this how you can take unstructured data and extract it and put it in your database using a fairly simple regular expression. This is very successful, and because I teach regexes in the class, it's not only useful for web scraping, but later on you'll find that some databases use regexes natively for search queries. I continued using a website called Metacritic. If you're familiar with Metacritic, it's a really nifty website that just takes reviews that are published all around the internet and it converts them into numbers. It says, all right, this newspaper gave this movie an A grade. Well, we're going to consider that to be a 90 out of 100. And then they average up all of those numbers and they produce what's called a Metascore, Metacritic Metascore. Metacritic has the advantage that the website is extremely simple and it's really easy to write regexes for it. But the other interesting thing is it allows me to teach the ethics of using other people's data. Because clearly what's happened is Metacritic is using data from other people in the first place. Metacritic is going to all of the reviewers out there, all of the newspapers, all of the magazines, all of the websites, and it's gathering data from them, and it's using that data and creating its own transformative use of that information. And so Metacritic is a transformative use, which allows me to teach in class about the concept of fair use. In America, the concept of fair use is a legal doctrine that says if you are doing something that is transformative, your use of somebody else's data can be considered acceptable, even if they own that data. And it's really interesting. And if you're interested in it, I would suggest you all sign up for my class at Bellevue College because I'll include that. A little bit too complex to go into here, but it's an excellent topic. The final end result, and I included a screenshot here of what I produce in Jupyter. I basically gather title, release date, description of the movie, the Metacritic score, and the thumbnail image. That's not a lot of facts, but you can do some nice and interesting things out of it. The next step here is that after I taught the class for the first time, I got into the Groundhog Day scenario. And Groundhog Day, of course, is an absolutely fantastic movie with Bill Murray, directed by the late Harold Ramis, and absolutely fantastic. If you haven't seen it, got to encourage you all to go watch it. Brilliant film. The thing about Groundhog Day is that Bill Murray plays a character who gets to live the same day over and over and over again. And each day he gets it a little bit better than the day before. He fixes things and he does a little bit better, a little bit better, a little bit better, until finally he becomes a successful person. And so I had the opportunity to teach the same class over again. After I finished teaching it, they said, all right, we like it enough. Would you do it again? I was like, excellent. I'm totally going to do this again. I will one by one delete the things out of the class that didn't work and add in things that I want to try. Oh my goodness. So unfortunately, I assure you this PowerPoint did look fantastic before I uploaded it into this presentation thing. So you may not be able to reach this. But I had a fantastic ethics section in class. I had wonderful discussions with the students where we talked about data leaks and data breaches. We talked very specifically about Facebook and Cambridge Analytica. And then we also talked about the Target 2013 data breach, which was a really astonishing hack where they gathered credit card numbers out of millions of retail terminals around the world. On the other hand, the recordings of lectures were a total and utter disaster. The instant I told students that I was recording my lectures and publishing them online, my attendance went from 25 students per lecture to 1. And I said, wow, as much as I like the idea of sharing these videos, I checked the metrics afterwards. Only 2 students ever logged on and watched the video. And of those 2 students, they only watched a total of 15 minutes out of a 2-hour video that I recorded. So I gave up on recording lectures. I tell students, look, every bit of information you need in the class is going to be in the PowerPoint. If you can't attend the lecture, it's okay, but come to the lecture. I'll try to make it fun. And this is my favorite, possibly one of my favorite movies of all time, Real Genius from 1985. I did get a textbook, and the textbook was okay. I fully recommend this textbook to anyone in this field. Designing data-intensive applications, there is an incredible amount of marvelous theory in it, The problem was that it was hard to connect the lessons in the book to the things that I was teaching. And as a result, I experimented a bit. I found a way that students could get the book for free using the Bellevue College library, but the end result was it just wasn't adding enough to the class, so I dropped the textbook. I eventually wound up with weekly assignments, and I added some quizzes. And the idea was that with the weekly assignments, I could ask students to do some reading, and then I would just give a really basic quiz where I would just check to see if they'd read the material. So that was more successful, and it also allowed me to have a quiet week. I wanted to make sure there was a little bit of homework every single week in this class because I wanted students to be engaged and remain engaged, but I gave them a quiz once in a while, and the quiz was just easy to breeze through in 10 or 15 minutes. It was a nice downtime. Well, this is something that I really wanted to do. I wanted to teach students how to create a database and how to start loading data into it and everything. And what I rapidly found is that as I was teaching this class, I would have a collection of 40 students. And out of those 40 students, some of them were already interns at Microsoft. Some of them were already employed with governmental agencies doing professional data analytics work. And other students were straight out of high school and they were struggling. I remember one student tried to ask me for help understanding their disk space. They had run out of disk space and they couldn't install something on their computer. And I was completely stuck. I did not know how to help this student understand the concept of disk space. So there's widely varying levels of skill. I gradually tried to remove things out of the software that required installations. Microsoft SQL Server has a truly awful installation program. I say that as a person who loved SQL Server since I started using it in 1997. But if anyone from Microsoft is listening, please delete your installation program and start over. It is not a good thing. Python ODBC is also terrible. So eventually I said, look, I'm just going to leave SQL Server out of it, and I'm going to find some alternatives. Well, next thing I tried was I tried VMs and containers. As it turns out, SQL Server on Linux has an absolutely amazing installer. If you use SQL Server on Linux and Docker, you can start the instance in 30 seconds by running one command. It's amazing. This is exactly what Microsoft should do. But even though I timed this assignment and I like recorded a video of myself doing this assignment in 40 minutes, I had students tell me that they spent 20 hours working on it and they never got it to succeed. So reluctantly, I dropped the section of the class where I tried to teach VMs and containers for database management. Eventually, I came across another idea, which is, why don't I try a NoSQL database? So I practiced a little bit, and I found that MongoDB has a free product called Atlas. And you can go to mongodb.com right now and click try it out for free. And within about 10 minutes, you can have a fully working MongoDB cluster. Costs you absolutely nothing. And it is perfect for teaching. It's perfect for teaching because I get to explain to students, this is why the cloud has taken over, is because the old way of doing things was frustrating and it was difficult and it was time consuming and you had to install software. It just didn't work. But now you go to the cloud and you can just click a few buttons and get yourself a free cluster. So MongoDB turned out to be a really successful addition to the class. And it was just an opportunity to teach something fresh and new. So I know I'm running low on time and I'm betting that we'll have some questions, but I'm just going to finish up here by sharing some slides about movie statistics, because some of you may have come here specifically to learn about movies, and I don't want you to get away without some interesting facts. All right. If you load the Metacritic data set and you plot movies over time, you will get a chart that looks like this. And if you see in this chart, there's a data point for each year and the quantity of movies. And I looked at this chart and I said, that's kind of odd. Like, why was there a spike in movies in 2005? Why was there a trough in 2009? Why did it spike? Like this doesn't make any sense. I would think that the number of movies would be steadily increasing year over year. Well, I use this as an opportunity to teach students, you know what? Every data set is a product of its limitations. The data set for Metacritic is the data set of movies Metacritic scored. And Metacritic publishes on their website that they only publish scores for a movie that has 7 or more reviews. So my theory here is that what you are seeing, the variability in this chart, is that in the early 2000s, Metacritic gathered reviews from newspapers and magazines. In the crunch of 2008, 2009, a lot of these newspapers and magazines dropped reviews of movies or reduced the number of reviews. Metacritic responded by gathering reviews from online sources, whereupon the quantity of movies went up again. So this doesn't mean that the number of movies is going up or down. It means the number of reviews that feed into this data set are going up and down. And I use this to tell my students, you can't simply say that this data set represents all of the facts. You can't say that this is the total quantity of movies. You have to say it's reviewed by Metacritic. The other interesting thing is that there isn't a lot of numeric data. And if you run reports with not a lot of numeric data, you will get spurious correlations. If you Google spurious correlations, you will find this absolutely fantastic website called Tyler somebody's spurious correlations site. And what he does is he produces charts that take two random things and show you how they have really strong correlation values. In this case, Tyler found number of films Nicolas Cage appeared in over years and number of people drowning by falling into a pool. And as you can imagine, this is totally 100% coincidental. But if you gather enough facts and if you don't have enough detail in it, sooner or later you will find silly correlations like this. What about Metacritic scores? This is actually rather interesting. If you plot a frequency distribution of Metacritic scores, you will see a chart that looks like this. And it is a skewed distribution with left bias. And what's happening here is that this is an artifact of the way people give movie scores. Essentially, what happens is people are much more specific about the numbers that they give when they give bad reviews rather than good reviews. So once a movie gets to the threshold of an 80% critic positive review, there's not a lot of variability. Pretty much everyone loved Titanic. Pretty much everyone loved, I don't know, what's a good movie recently? Avatar. Pretty much everyone loved that. So those movies are going to get high scores, but then you get to the real dregs. You get to get like the hacked movies and the slasher films and things, and people are going to say, "Oh, this was bad, but not as bad as the other one." They give a lot of detail there. So what you're going to find is that on the lower end of this scale, there's a lot more variability than on the higher end of the scale. Let's skip this one. Let's just keep going because I think I'm a bit low on time. I also gathered facts from the Internet Movie Database. And this was interesting because I wanted to teach gathering data from IMDb, but I was never able to figure out a way to do this without making it too prohibitive. So I ended up producing a scraper for Metacritic that took about 50 lines of code in Python, and I figured I could teach students how to do it. Runs in about 10 minutes. It's easy for me to explain to students how that works. On the other hand, the IMDb scraper wound up being 400 to 500 lines of code, and it takes 2 days to run completely. So I just skipped the IMDb side and I just share that data to students. But once I get IMDb, I get a whole bunch of interesting facts. I started getting facts about the length of movies, like their run times. And I would see weird things like this. So obviously, if you plot this over time, the average movie is somewhere between 90 minutes and 200 minutes. Most movies are an hour and a half to 2 hours long. You get a little bit longer than that. You get, some movies that are up to 200 minutes long. That's about 3 hours and a bit. Nowadays, all the Marvel movies are getting really long, aren't they? So I looked at this and I said, this makes sense, but what the heck are these numbers way out here? There was one movie that had a runtime of 500 plus minutes. What's going on? Is my scraper broken? Is my code broken? And so I teach students, you have to look at this data. You have to run this chart and say, is my scraper broken? Am I gathering bad data? Well, the answer is I'm not gathering bad data. I'm gathering data about a movie that doesn't match my preconception of what a movie is. As it turns out, there was a movie called Shoah, which was a 9-hour, 30-minute film. It was released in theaters, and it was essentially it's a kind of documentary style film about the Shoah, which is also known as the Holocaust in World War II, when Germany and the Jews, we don't need to get into it, but this clearly is a real movie. It was actually in movie theaters, and this is a real world outlier. If you are preparing charts, you have to make sure your charts accommodate real data, even when that data seems odd. On the other hand, here's another fact. There was a 4-hour, 20-minute Batman movie. 4-hour and 20-minute Batman movie. Turns out it was actually called Batman Serial. The Batman Serial. And this was something that happened in the 1940s where they would produce shorts. And the shorts would all together add up to a story about Batman. But what they were doing, they basically released them before another movie. So kind of like the way Bugs Bunny cartoons used to be shown in front of a film, they would put a Batman short in front of the movie. So this is probably not what I think of as a movie, and I would probably exclude this if I was doing analysis. Well, next thing I did is once I had data from IMDb, I had budget. And IMDb has what it thinks is the estimated budget of a movie. And I ran this chart and I'm like, that's interesting. There's a number all the way here on the top right-hand side. And if you look at where that is, it says that the movie's budget was $120 billion. $120 billion. That is probably what you spend on like the F-22 fighter program. So does not seem like a movie. What's going on here? I thought Avengers Endgame was the most expensive movie of all time. What happens? Well, the answer is that this was a movie in a different currency. So I dug into this, and it turns out that 120 billion Iranian rupees, IRR. This movie was a film about Muhammad, the messenger of God was the name. And this is technically, again, valid data, but it illustrates to me a different type of outlier analysis. So again, I teach this to students and I say, you need to look at these outliers and you need to figure out why you are including something or not including it. All right, so we're coming to the end here. I know I've gone just a little bit over time, but let me share some students' data. This is an absolutely fantastic chart that a student produced showing total profit per studio. So what this student did is they took box office returns minus budget for every film, and then they grouped it by studio. And the end result is that Marvel Studios is far and away the most successful studio. And I think that's just because they're all recent films and, recent box office numbers are more dramatic. This is another chart. This is maybe not the best chart because it includes scientific notation rather than financial, but it basically shows this is what I remembered from growing up in Los Angeles. The opening weekend of a movie is very strongly correlated to the long-term box office numbers. And if you run this chart and you show this correlation, there is basically a linear correlation between these two. Whatever opening weekend a movie gets, you can use that to very strongly predict its results. And if you add in the movie's score, you basically get an even more accurate forecast. Here's another good one, total budget for superhero films. You can see that this goes nuts around about 2003. I think that's about the time that the X-Men movies hit it really big. And so everyone said, wow, these X-Men movies are hugely successful. They've made 2 of them. Let's start making a bunch more. And they start making Spider-Man and a whole bunch of other things. Another question that I commonly get is, do studios save their prestige films for the end of the year? And the answer is, if you say number of movies with scores above 89 released each month, the answer is studios totally save them for October, November, December. So if anyone says, are the best movies at the end of the year? Well, according to this metric, yes. You may not always want to see a prestige film. Sometimes you may be just in the mood for a mindless popcorn film, but Prestige films do generally come out at the end of the year. Here is a student who did the actual more complex regression analysis, and they actually produced a formula. And the formula was that the sales to the power of 0.31 equals this formula combining budget plus rating. And this formula is incredibly successful. And if you look at this, this formula does not include opening weekend. This formula is something you could use to try to predict the success of a movie without knowing its opening weekend numbers. So this was super exciting when I saw a student went and did this. This chart right here is my absolute favorite of all time. One of my students found a Python library to analyze the number of colors in a movie poster and took this report and plotted it against the film's overall review score. And what they demonstrated, according to this, is that there is a significant, consistent negative correlation between colors in a movie poster and the movie's review score. And I think what this implies is that prestigious movies often have simpler posters than lower budget films, less famous movies. Anyways, I thought this was absolutely amazing. So I want to thank you all for coming out here and really appreciate the opportunity. Thank you to Big Data Bellevue. Thank you to Microsoft. I'd like to make sure that I have some time for questions if you want to. Thank you. Sure. If anyone would like to ask, please feel free. I'll hang out for another 10 minutes or so, and then we can just chat. Yes. I believe so, yes. If you look at it, the exponent factor, I do believe, is makes it logistic regression. I would have to go back to the actual assignment to see what the model was that was used. But I think this was done using pandas and NumPy. What about marketing budget? Well, tell you what, nobody has good marketing budget information for movies. So the question here is, can we add in marketing budget? Well, there is one company that does gather this data, but they do not make it available for free, and it's not available publicly in a place that I could scrape it. I have worked with the people at Nielsen, at AC Nielsen Company. They do gather this information. So if anyone out here is interested in doing research on movie advertising budget, it is possible to partner with Nielsen, but you would have to convince them, and hopefully you have a good story as to why they should collaborate with you on that. Additional questions? Yes. So the question was, how is the quality of the energy data? And the answer was that when I started putting this class together, IRENA published their reports and they published their data set. But their data set at the time was only the raw numbers that appeared in the charts. So I tried figuring out a way to do it, but those numbers were already digested in a form that only made them useful for that one chart. And so the overall teaching value of sharing that was not that great. Most recently, IRENA does now publish the raw numbers. So you can actually go to IRENA and get the raw facts. But at that point, my class was already structured around superhero movies. And I just said, you know what, I'll come back to that at some point in the future when there's another opportunity. What I will say is that IRENA's data is really good in terms of they separate between auction and actual. So auction is the bidding that people do when they're about to produce a new power plant, and actual is the final cost once they've started producing power. And those two numbers have diverged for a while, but they're getting to be more predictable now. Another question? Question was, what's the most useful analytic tool, in my opinion, right now? Well, depending upon how you look at it, I would say Visual Studio Code with the Jupyter plugin is my answer for this. Because what I like about it is I can teach people very straightforwardly. I can teach them, here's how you install NumPy. here's how you install pandas, here's how you install matplotlib, and one by one, all of those things work together. So my experience with R was that there were a ton of plugins, but like every individual plugin that I was teaching in R was unique. When I go to Python, the Jupyter and Python world, I know that what I'm teaching has relevance beyond just that data analytics. So it's helpful in not only teaching students, here's how to create a chart, but here's how to use Python to export and import data, a whole bunch of things. So that's why I'm really fond of Jupyter and that Python environment. Did I ever consider using geodata? Do you mean like mapping? So I'm generally limited in this class by what I can put together and adequately explain to students afterwards. So there's an interesting phenomenon that somebody told me about, which is that a teacher is often scrambling to figure out what to teach the weekend before they give a lecture. And so what I found is I often realized, oh my gosh, my next slide doesn't work. I need to redo this. And so I would have to rapidly come up with a report. And once I came up with the report, I would be like, okay, now I can teach this and I can use my report as an answer sheet. So I never came across a geodata set that worked for me, but it's not to say that there aren't any out there. Question?
Would you consider using movie stars because they have a big effect on what happens and the characters?
Yes, actually. So the question is, did I consider using movie stars? Yes, we do actually teach movie stars. One of the slides that I do is comparative movies with one movie star versus another movie star. The problem is that movie stars generally are in, 1 to 5 movies per year. And what usually happens is that a movie star is in maybe 1 or 2 big name movies, and everything else is usually a really low budget student film that they do just for the prestige factor. And so what you'll wind up with is if you run that movie star project, you'll see Robert Downey Jr. way, way, way up at the top because he only appeared in these Marvel movies. And everyone else is much more average because they have a mixture of big budget films and low budget films. I was originally considering including a slide on that here in my student collection, but it wasn't as good as some of these others. Like I really wanted to focus on this movie colors and posters thing. So yeah, we do use it.
But in a broader
Mhm.
what I found is you sort of hit a ceiling with this is kind of VDA to me, exploratory data analysis. And until you hit a ceiling, you have to go back and study the domain. And the more you know about the domain, now you can get further and further. So like I think you mentioned, like regionally, what happened, based on who was in it, what genre was it, what franchise. So the more you spend time in the domain, the further you can go in there. So you cover that as well.
That's a really good point. For those of you online, the question was, do I explain the domain of the data? Do I explain how to go back and dig into the data? So for a long time, my class included 2 sections, two lectures on presentations. And the idea was I'd do the first lecture and say, let's produce a Jupyter chart. And then I'd do a second one, which says, now dig in deeper. And I found after experimenting with this with some students that like there were students who were struggling to complete the first charting assignment. And there were other students who were already doing amazing work with in-depth analysis and everything. And adding in the second deeper dive lecture did not help either side. The students who were lost were still lost. The students who were doing great work were still doing great work. So I eventually dropped that and I just included some discussions about, hey, when you run your reports, you need to look at outliers and see this outlier can teach you how to filter your data better. You can see this and propose a new question to ask and a new research to dig in. So I talk about it, but the class is broad enough that I can't include everything. Yes, yes. Mm-hmm.
graph databases, which can bring some very interesting things to light. And people can see a lot of
Yeah.
correlations they wouldn't see otherwise.
In an early iteration of the class, and the question is like asking about like, teaching different types of databases and different functionality there. In an early iteration of the class, I included both SQL Server and MongoDB. And I was really excited about that, but everyone struggled with SQL Server, and then MongoDB was just so good and so successful. I said, how about I try cutting out the things people are struggling with? Because like one student would say, oh yeah, my boyfriend installed SQL Server on the computer at home, but I can't get to it. And I would have to explain firewalls, and I would have to explain authentication. I would have to explain networking. And then they'd be at a Starbucks and they'd say, how come I can't talk to SQL Server now? Well, it's because your Starbucks can't route to your home network. And so it was just too much to explain. And as a result, the MongoDB Online was the right level of detail.
One last one is that this is all for the person doing the analysis with the data directly, but often when you do a BI dashboard,
Mhm.
that's entirely different because you're giving it to the domain expert now rather than the data expert. And if you give them a dashboard, they can go off and do their own analysis and go deeper. And then there's just a presentation where you might use a Boca or Shiny, D3 or Black.
Mhm.
So you cover sort of self-service analysis using dashboards or web-based graphics.
Yes. So the question was, what level do I cover dashboarding and self-serve intelligence? And the answer is, I did try to cover this. I tried to explain to students how creating a pipeline to export data in a format that could then be diced for display. But again, that was just one of the topics that students really didn't grasp. And it was harder to explain that because I couldn't get them to the point of setting up a dashboard with sliders and things. So I decided to just focus on running reports in Jupyter and doing that. And I talk a little bit about it. But that book that I shared earlier, the Data Intensive Applications, that has some amazing discussions of how to create good dashboarding systems and um, uh, immutable pipelines and things like this. Yeah. Yeah. All right, I think I got time for one more question. All right, last question. Yes, Mhm.
I think it's a little bit different topic from data analysis. So I'm interested in the response from your students.
Yes, so that's exactly the point here. So the question was, this audience member here is reading that book, Designing Data Intensive Applications, which I talked about earlier in the conversation. And this book, Data Intensive Applications, is not the same thing as data analytics. It is about what is a good application and how does the application work. And so when I originally had the concept that I was going to teach how to build a dashboard, I wanted to explain this is the theory behind how you build a dashboard. But this class is a 10-week class. It's sometimes 10 weeks and sometimes 11 weeks, depending upon the circumstances of the school schedule. So I had to limit the amount of material that I could teach to what could be done in this time period. If I had a 3-quarter class where I taught quarter 1, quarter 2, quarter 3, a continuous process, I could probably do a lot more and cover building an application, importing data consistently over time, and then updating the dashboards after the fact. But this data intensive application, I read it and I was like, these are incredible ideas. Students need to learn them, but they were not practical enough for the class. And what I learned as a teacher is that I couldn't include everything in the class that I wanted to. There were so many good ideas. I was bursting at the seams with ideas I wanted to teach. But my experience of working with real world students is that I needed to give them a more focused, a smaller subset of what I was thinking to teach. And so that's why I wound up with a smaller class than I originally imagined. It doesn't aim to accomplish as much, But what I do want to do is to get to the end with every student who participated in the class gaining a knowledge of this system. And that's it for me. So thank you so much. I really appreciate the time. And I would love to hear from you online. Oh, I didn't include a slide at the end. Please visit me on tedspence.com, or you can look me up on LinkedIn. I'd be happy to chat with you all. Thank you so much for your time. Do you want to finish up the? All right. Thank you, everyone online.